Namaste students, myself Juvi and Dr. Kiran Yadav. In this session I will discuss about light dependent resistor. So let's start with the introduction of LDR. The short name of light dependent resistor is LDR, or it is also known as photoresistor or photocell. It is a light controlled variable resistor. Its resistance changes with the light intensity that falls on it. The resistance of a photoresistor decreases with increasing incident light intensity. In other words, it exhibits photoconductivity. The resistance range and sensitivity of a photoresistor can substantially differ among dissimilar devices. So this is a typical LDR, and this is how it actually looks. And in the other diagram there is circuit symbol of LDR shown. LDRs are made up of semiconductor material having high resistance. Photocells or LDRs are nonlinear devices. Their sensitivity varies with the wavelength of light incident on them. Some photocells might not at all respond to a certain range of wavelengths. So let's understand now the working of LDR. And LDR works on the principle of photoconductivity. Photoconductivity is an optical phenomena in which the material's conductivity reduces when light is absorbed by the material. When light falls, that is when the photons fall on the device, the electrons in the valence band of the semiconductor material are excited to the conduction band. These photons in the incident light should have energy greater than the band gap of the semiconductor material to make the electrons jump from the valence band to the conduction band. When light having enough energy is incident on the device, more and more electrons are excited to the conduction band, which results in large number of charge carriers in the conduction band. The result of this process is more and more current start flowing, and hence it is said that the resistance of the device has decreased. There are two different types of LDR, intrinsic and extrinsic. So let's see what are the definition of both of them. So first, intrinsic LDR. These are pure semiconductor materials such as silicon or germanium. Electrons gets excited from valence band to conduction band when photons of energy falls on it and number of charge carriers increases. Second are the extrinsic LDR. These are semiconductor materials doped with impurities which are called as dopanes. These dopanes create new energy bands above the valence band which are filled with electrons, hence this reduces the band gap and less energy is required in exciting them. Extrinsic photoresistors are generally used for long wavelengths. Now the characteristics of LDR. LDRs are light dependent devices whose resistance decreases when light falls on them and increases in the dark. When a light dependent resistor is kept in dark, its resistance is very high. The resistance is called as dark resistance. It can be as high as 1012 ohm. If the device is allowed to absorb light, its resistance will decrease drastically. If a constant voltage is applied to it and the intensity of light is increased, the current starts increasing. When light is incident on a photocell, it usually takes about 8 to 12 microseconds for the change in resistance to take place, while it takes seconds for the resistance to rise back again to its initial value after removal of light. This phenomenon is called as resistance recovery rate. LDR or photocell are less sensitive than a photodiode and phototransistor. A photodiode and a photocell are not the same. A photodiode is a p-n junction semiconductor device that converts light into electricity, whereas a photocell is a passive device. There is no p-n junction, nor it converts light to electricity. If the light intensity is kept constant, the resistance may still vary significantly due to temperature changes, so they are sensitive to temperature changes as well. Extrinsic light dependent resistors are generally designed for longer wavelengths of light. with a tendency towards the infrared. When working in the IR range, care must be taken to avoid heat buildup, which could affect measurements by changing the resistance of the device due to thermal effect. Now let's see the construction of, so we will study the construction of LDR in the next session. That's all for this session. Thank you.